Hi, I am Hannah Judge. I am a technical account manager at Mapbox. And before we get started, I thought I would tell you all a little bit about myself. So I spent a couple years helping small community health organizations gather road and demographic data in remote regions of Liberia and Peru to help inform site selection for new health facilities. So we would help train local data collectors in using GPS and Android phones and actually ride around on motorcycles or travel by foot through areas that didn't have any roads at all. And now I am immersed in the Mapbox world and helping companies think, what does it mean that we are living in this geolocated world surrounded by an ever increasing number of sensors that are pinging other sensors, finding us in space, and telling us where to go, how to get there, who and what is around us, right? And maps help us tell all of these different stories and ultimately answer the question, why do things happen where they happen? Tableau is such a powerful tool because it helps people tell stories with data, and maps are a really key part of that. So today, I'm going to tell you about how you can take advantage of more location data in Tableau to build better maps, better dashboards, and ultimately have more impact. So here's what we're going to look at together. I'm going to talk about 3 of my favorite Tableau mapping features, and then 3 ways to extend the location capabilities inside of Tableau using Mapbox. And my hope is that by the end of this session, you will be so inspired to go make a new map in Tableau, and you should definitely tweet it to me when you make it. My handle is HMJudge, or you can tweet at Mapbox. Okay, and note that we'll take a couple minutes at the end for questions, as Jesse mentioned. So, what is Mapbox? Data and net platform. And we build open source tools, so maps, search, navigation, directions APIs, all these different SDKs that help our customers make the most out of their location data. And really, we like to think of our products as Legos, right? You can fit them together however you need and use them to answer your most complex location questions. And we power the maps for companies like the Weather Channel, who use maps to help keep their users informed about daily weather and also severe weather, making sure you get an alert when a hurricane or a snowstorm is headed your way. Or for the New York Times, who uses Mapbox to visualize election results, or Tableau. They now use our maps in all of their products. So we don't have an app of our own, but we power the location services inside of other people's apps, which means there are over 640 million monthly active users touching Mapbox every single month. And because of this, we're getting about 9 billion miles of new anonymized location data every single month. So what do we do with that data? We like to talk about our map as a living map. Developers, they build with our tools, then they share their apps with their users, and we get all that anonymized location data back from the apps, none of which I should mention, none of it can be traced back to the individual or any personal information, right? It's all about the map and making it better. Where is there heavy traffic right now? Where is there a new one-way street? But I think this audience, if you're here and you care about Tableau, mostly you care about data. So I want to highlight 2 different things that are unique about Mapbox that should resonate with you, and they both have to do with layers. So first of all, layer orders are really important in a map because they give you design flexibility. With other maps, you're often placing your data on top. So say you're making a choropleth map showing population by neighborhood. You don't want the data to sit on top of the map, right? Because then it actually obscures the labels. So you can't even really see what neighborhood you're even looking at. With Mapbox, you can slot your data in between the layers. So you have the geographic context and streets underneath your data, but the state borders and city names on top of them. So this is a snapshot of the weather company's Storm Radar app. And it's important that the labels sit on top of the radar data so you can actually see what places are in the storm's path or in an evacuation area. Second cool thing about layers is that the data that's baked into the Mapbox layers provides you with an enormous amount of information, right? It helps you answer common questions in the automotive space, business intelligence, energy, real estate, you name it. We have 3D buildings, HD map data that can be used to inform autonomous driving, POIs, traffic signs, terrain data, everything all the way down to the base map and satellite. And when you're building with Mapbox, you can actually pick and choose what data you want to pull onto your map. And as of 2019.2, you can access Mapbox vector maps directly in Tableau. So before this release, Tableau maps were using raster tiles. And with raster tiles, if you're familiar, like when you load a map for the first time, you sort of get that gridding effect as you zoom around while you wait for the new tiles to load. But with vector maps, the maps are faster, smoother, and sharper. And these maps are powered by Mapbox. So we worked with the Tableau Maps team to help launch fresh new default styles for all of their users. And it's been very fun to follow along with everything that the Tableau community has been making with these new maps. So I'm going to highlight 3 of my favorite things about them. First, satellite maps. Second, more administrative data. And third, layer toggling. Okay, up first, satellite maps. So in 1997, over half of the countries in Africa were affected by conflict, resulting in nearly 1 million deaths, massive displacement of people across the continent, and major economic costs, which hindered development of multiple different African states for years to come. The Armed Conflicts Location and Event Data Group collects data about the dates, agents, location, number of fatalities of all the reported political violence and protest events across the African continent. So what we're looking at here, this is a dashboard from Johnny Walker, which illustrates where conflict has occurred on the African continent over a 20-year period using the ACLED data. And the maps help paint a picture of these fluctuations of unrest and violence over time and really highlight where are those hotspots. And using satellite imagery here, it's an interesting way of representing the data, right? Because the country labels are off. So the focus is really on regional trends. But you imagine without the imagery, right, those large desert areas might stand out as places where there's not a lot of violence. But in reality, the imagery helps remind us that those desert areas are far less populated. So if you're a researcher analyzing trends in political violence, how those relate to GDP of a particular country, for example, right, this is a valuable way of quickly contextualizing your data and focusing in on the areas that really matter most. I'll show you 2 cool things you can do in Mapbox Studio if you want to customize the imagery even more. So Mapbox Studio is our map editing tool. It is free to sign up. You can use it to create custom map styles that you then pull into Tableau and use as your default base map. I live in San Francisco, and wildfires are increasingly on my mind in California. So here we're looking at wildfires over a 24-hour period. I can see the dots when I first place them on the map here, but they're not super visible, right? They're pretty small, they're light red. I'm not thrilled about making them larger, but I do want to make them more visible. So I can go into Mapbox Studio here and actually adjust the opacity of the satellite layer and help those points really pop. So this is a nice technique to use when you want to use satellite data, but in a more subtle way. Another cool subtle technique is what I like to call a satellite fade. So say I work for a real estate company, I'm interested in imagery because it'll give my customers that awesome sense of the landscape, what neighborhood are they moving into, but I don't necessarily want to start with that perspective, right? A more typical streets view is still useful at some zoom levels. So what I can do is set the imagery layer, again, using Mapbox Studio. I can set it to fade in to that satellite view once we actually get down to a certain zoom level. So I get the context I want when I actually want it. To start using satellite imagery in Tableau, you can now just head to the Map Layers menu option and select Satellite from the drop-down menu of background map styles. Okay, my second favorite feature, boundaries and administrative data. Guy's and St. Thomas's Charity is an NGO in the UK, and they're working to tackle urban health issues like childhood obesity. Rob Parker is their head of data and analytics, and he has this great story. Tableau recently published like a showcase on them, a little video profile. And he talks about being asked by his CEO, where should we start doing this work? Where should we start tackling this problem? They want to visualize their data, identify areas with high obesity prevalence, and then confirm that the areas with the highest need are actually the places where funds are flowing, so they're having maximum impact. So you can see here in this map, they've used Tableau, and they've joined their data to those neighborhoods. Those are the red polygons on the maps here. And they're able to then place additional data on top of the map and think about how to work with existing local resources in this case. So Mapbox is now providing the updated administrative, postal, and statistical boundaries data to Tableau. So you can join your own information to even more administrative areas like this: zip code, state, county, and visualize it in maps like this. And if you want to get really fancy, you can. Hex bins are a great way of showing general themes over a geography. Right, they're less granular than a dot density map, and they're not constrained by boundaries, as is the case with choropleth maps. And temperature data is a really great use case for hex bins because weather is not affected by politics, and it doesn't really pay attention to administrative boundaries. So if you're doing climate research and you want to hone in on a specific geography with an average temperature above a certain threshold, for example, you could use a map like this to define that region. Alan Walker, my coworker and Tableau viz extraordinaire, he made this map showing the global monthly mean temperatures in 2013. And he used QGIS to create the hexagon grid, which he then intersected with the Mapbox boundaries layer, kicked off a magic-making process where he basically processed and exported all of those intersections as raster files. And then he used Alteryx to do some spatial matching, run a summarize function, run a union function, then applied quantiles in QGIS, and ultimately brought all of that back into Tableau in this visualization. If you didn't catch all of those step-by-steps, I think he has a tweet on his Twitter profile that walks through how he made this cool map. So to start using boundaries yourself directly in Tableau, you don't actually have to change anything. If you're making a map in Tableau as your data by county, you're using them. And if you're not seeing the data that you need included, definitely let us or the Tableau Maps team know, and we'll work to add it. Okay, final favorite feature, layer toggling. So going back to my fire data, I'm using the light style here, and I'm showing the location of fires over the past 24 hours. Let's say I run a shipping company where I'm delivering produce to different grocery stores all over California, and I want to know, how are the fires affecting my operations? How might they affect those? See that there's been some fire activity north of San Francisco here, which is a region I service. There's not a whole lot of context on the map though. So I can open up this map layers tab to the left and actually select the layers that give me the context I need: terrain, cities, points of interest, roads, all of that. And I can see also what other layers exist in the other styles. So here, if we click, just looking here, yeah, so there I'm turning on streets. And depending on what style I'm in, so here again, I'm in the light style, but if I want to actually see what styles are available via outdoors, I can do that as well. So you don't have to change anything to use this feature either. You can just use the latest version of Tableau. Okay, so those are a few of my favorite Tableau Maps features. At Mapbox, though, we're always thinking, how can we help smooth out any rough edges that currently exist, enable Tableau users to do even more with their data using some of the Mapbox tools? So I'm going to highlight three things: offline maps, geocoding, and isochrones. If you work for the government or a bank or a hospital and firewalls and HIPAA restrictions are a part of your everyday operations, you can hook Mapbox Atlas up and get access to your maps and all of your data completely offline without losing any detail or functionality. So until 2019.2, that's a Tableau release, you couldn't use maps offline in Tableau, full stop. With Mapbox, though, you now have the option to extend what Tableau offers out of the box by integrating Mapbox Atlas. So let me show it to you. Okay, so this is a standard Tableau dashboard using the Superstore data. We're going to plot the data by state just to generate this map, pan around a little bit, zoom in and out, turn a couple layers on and off. So now I'm going to turn off the Wi-Fi to simulate being behind one of those firewalls. Wi-Fi off. The map stays, right? But you don't get any more detail. And Tableau is really smart, actually, about caching what you already have loaded into the browser here. But what about getting more data? So if we pan over here, now we're in Germany, we can see the shapes, but as we zoom in and out and turn off and on the different layers, we're not actually getting any more detail. Or if we try to switch to a new style, see what happens. Actually looks like it's like hanging here for a minute. Eventually it will let us switch the color, but there won't be any more detail, again, loaded in there. Okay, cool, boom, same area. There we go. So now let's try Atlas to fix this. So I go up to the map and I select Atlas, which I've already loaded in here. Boom, same area, much more detail. If we go back to the United States, we can zoom, we can pan around. As we do that, it's pulling in more data. I can toggle on and off into the different styles, the different layers. It's the same great experience that you expect in Tableau, but we're now totally offline. So unlike the previous examples, this is not a feature that's actually available out of the box today. And this is showing an environment that has already been hooked up to Mapbox Atlas. And to make that process even easier, we are launching a new integration and we're calling it Tab Atlas. So with the same information that you need to plug in a custom map, you can now make Atlas the default for all of your Tableau needs. It's available on GitHub now, it's well documented and ready to integrate. So yeah, we're super excited to be able to offer this alongside the Tableau Maps team. We were at the Tableau conference a couple weeks ago and heard from multiple people that they were excited about this. So if this speaks to you, check out our Tab Atlas solution. You can go to mapbox.com/solutions/Tab Atlas. So the second tool I want to tell you about is geocoding, also known as search. So every time you're in an app and you're searching for an address, whether that's the weather app or DoorDash, Lyft, and you drop a pin on the map, you're making what we call a forward geocode. So say we're in Las Vegas, I want to see where in the city the conference center is that I'm heading to, search for Mandalay Bay. This is what the response looks like. I get the name, I get the lat long. Also, say I'm lost in said behemoth conference center, or I'm in a shopping mall or an airport, I want to use an app like Yelp to try and find some good food. And instead of putting in my address, I can select my current location, the lat and long, and that's making a reverse geocode. So in Tableau, I can use pretty much every geographic data format, but what if I have a long display those stores, bring them into my dashboard, put them on my map in Tableau, but when I upload them, there's not actually enough information in the address data alone to plot the points on my map. Geocoding is the process that helps us transform address data into something that you can actually put on the map. What I'm going to show you next is how to do geocoding directly in Tableau Prep using TabPy. For those of you who aren't familiar with TabPy, it is an open source solution. It's built by Tableau that allows desktop, Tableau Desktop, and Tableau Prep to run Python code using your data and return those results directly to your application. If you've never written Python before, remain calm. My coworker, Chris Toomey, he did it for you. Basically, we were inspired by how TabPy works with Tableau Desktop to enable anyone to leverage the functionality of a script that's been pre-written. So you don't have to write any new code. You can literally just copy and paste it in, and it'll go ahead and call your function. Okay, buckle up. This is the most technical part of this presentation, and it's only 90 seconds. Shows how everything is possible today. So remember, I have two addresses, right? I have two Mapbox offices. I have these addresses, but I don't know where they are, and I want to put them on the map. So what we're doing here is we're building TabPy. This takes a couple minutes, but is the key to making this simple, because basically it's referencing all that code under the hood that we've already set up for you. So we're building it out here. Then we go into Prep Builder, where we grab the data that we want to geocode. This is the text. There are those two addresses. Now we're going to add a script and connect to the TabPy instance that we just built. So we're connecting here, browsing, Here we're going to select our simple geocoding script. So you can see this is where the 3 lines of code are. These are the only 3 lines of code that you actually have to keep track of. And what they're doing here is making a forward geocode. So we set that up. Now we're going to have to plug in our Mapbox access token. And this is how you actually make a successful request to the Mapbox geocoding API. You get a token when you sign up for a Mapbox Studio account. It's a free process to sign up. So here, copying and pasting in our token. Then we're going to pick our function, which is called prepgeo. Browse for that, prep forward. Yep, prepgeo, plug in the function, and boom. The latitude and longitude are now generated for those 2 addresses that we passed into prep. So if you're sitting here thinking, okay, that's great, but that was like 2 addresses and I have 10,000 addresses, we have something for you as well. We built a small deployment script in partnership with some folks at Pulumi. If you're interested in doing this at scale, definitely send us a note and we can get you set up with everything you need. So if this problem, addresses without latitude and longitude information, is something that you're struggling with in Tableau today, check out the repo on GitHub. So we've made this totally open source. It has step-by-step instructions for how to implement this solution today, as well as a list of prerequisites and, again, step-by-step to get you there. So you can go to github.com/mapbox/Tableau geocode. The third and final Mapbox tool that I'm going to talk about is isochrones. So think about this. I left my own direction. How far could I actually get? If I travel that same 30 minutes in every direction, you start to define a polygon, or really the polygon is of like, what is the accessible area? And map makers call this kind of visualization an isochrone, from the Greek words meaning iso, which is same, and chron, meaning time. And at Mapbox, we think about this in terms of time and how you travel, whether you're driving, walking, or biking. And it's not just about how far you can travel as the crow flies within that accessible polygon, but more concretely, how far can you actually get along a road network? So here I can specifically see how far I can travel along a road, in this case by bike, if I only have 30 minutes. Looks like I can get actually pretty far, almost to Daly City. And isochrones can be used to solve all kinds of problems, like the age-old, very important question, where shall we meet for a drink? My teammate Brian made this cool demo fondly called Meet Me in the Middle. If you Google that plus Mapbox, you can find it. So here I am. I was staying at the Mandalay Bay in Las Vegas. My friend is at Caesars. We're both trying to walk somewhere, find a bar in between us. Looks like there isn't really a good place within 10 minutes, so I can switch it to 20 minutes, 30 minutes, and see like where are the best places for me and my friend to meet that are equidistant and require the same amount of travel for each of us. So this is a fun example that you can actually use that illustrates how the isochrone API works. But also think about being able to use this type of visualization and binning technique to answer questions that you're facing every day at work. Where is the closest outdoor space from the apartments I'm showing my client? How many of my employees could reach our new office within a 20-minute drive as we evaluate new locations and run out of site selection? What restaurants should I service for my new food delivery app so we can commit to a 30-minute delivery window? All sorts of applications. But it's hard to find a more compelling example than Bridges to Prosperity. So B2P works with isolated communities to create access to essential healthcare, education, and economic opportunities by building footbridges over impassable rivers. They're currently working with local stakeholders in 20 different countries to build 316 bridges that serve more than 1 million people worldwide. Imundu is a 7-year-old girl. She lives in the Gasabo district of Rwanda. Before the bridge was built, Imundu would have to leave her house at least 3 hours before school started. She and her dad would walk all the way down to Nyachanga, wade through the river, take a bike taxi to the main road, and then take a motor taxi to school. Took 3 hours. And if there was a flood, they couldn't cross the river at all, and she would miss school for days at a time. Now, Amundu walks 45 minutes to the river, which has a Bridges to Prosperity footbridge installed. The bridge takes her to a road where she can catch a moto taxi, which takes her up the hill to school. It still takes about an hour and a half total, but that's half of what it took before, right? And that extra 3 hours a day that she gets back makes a really big difference in her life. A footbridge for someone like Amundu, it's not only an integral part of her journey to school, but it's actually a really important part of her story of academic success and eventually her livelihood. So in partnership with the Rwandan government, Bridges to Prosperity has just launched a scaling program that will build 350 new footbridges over a 5-year period to create safe access to essential services for over 1 million people. And B2P is constantly seeking to increase their efficiency and extend their impact, and also communicate to their stakeholders and partners what that impact actually looks like, especially with this new scaling program. And they're getting a lot of support from the Tableau community to do that. Salesforce, Alteryx for Good, Star Schema, Datablick, Tableau Foundation, and Mapbox are all coming together to help them visualize the impact. So using the locations of planned footbridge sites, those are the red dots on this map that we're seeing, and the locations of schools and health centers, which have been sourced from the Rwandan Statistics Agency, Bridges to Prosperity can actually visualize what the safe access looks like that's been created for hundreds of isolated communities as a result of this program that will be created. So the Impact Dashboard pulls spatial data from a number of different sources: WorldPop, the National Institute of Statistics of Rwanda, OpenStreetMap, and Bridges to Prosperity's own Salesforce database, and uses all of that to estimate what the immediate impact will be of those footbridges. Using the Mapbox isochrone API, we calculate an area for each bridge site that represents the distance that can be covered with a 60-minute walk before and then after the bridge has been built. So those are the spidery looking lines on the map under those red dots, are actually like showing the polygon, right, of that 60-minute isochrone. And then we find the villages that intersect these areas, and using the Mapbox Directions API, calculate the distances and durations from villages to the capital city of Kigali, to schools, and to health facilities. So let me zoom in and I'll show you what this actually looks like. So here again, the red dots are representing bridges. Each bridge has a Salesforce opportunity, so the box in the bottom right, the name, the status, and it calculates how many people live within 60 minutes. What are the different villages, how many villages are in this catchment area, how many schools, health facilities. And the box in the top right is what it looks like to zoom in on that red dot and break out that spidery visual. And that's the isochrone. So polygon showing the accessible area within 60 minutes walking distance that includes all of those villages, schools, and health facilities that we see below. In this view, the red dots are schools, not bridges. And so we're calculating the time and mileage to schools before and after the bridge construction, again, using Mapbox isochrone and Directions APIs. And the inset map in this case, on the upper right, shows all the different routes that can be taken to the schools. And in the data breakdown, in the bottom right, you can see that the bridge helped cut the distance and duration from the village to the school in half, right? 30 minutes, now 15 minutes, making a big difference in the students' lives. And it's not only schools. So here the dots are showing clinics and all of the routes from villages to clinics. From Bahanga to the closest health post, Kitakama, it used to take over an hour for people to walk the 10 miles to that health post. You can imagine if you're having a medical emergency or giving birth, walking an hour is really not an option. But with the bridge in place, it now takes less than 20 minutes, which drastically improves access. So what we expect to happen over time, as more bridges are completed, we'll add ways, which are these yellow lines, and we'll do that in OpenStreetMap, connecting the bridge sites to the existing Rwandan road network. And the effect of this will be that we'll be able to see that isochrone area grow. adding more villages within a 60-minute walk, thus connecting more people to critical services. We'll also be able to visualize and report both the distance traveled and the time it takes to get to those destinations, schools, clinics, etc. And couldn't help but share, very exciting. I think it was, 2 weeks ago now, 2 or 3 weeks ago, that the team added their first bridge in OpenStreetMap a couple weeks ago. So very exciting to see this work get off the ground. So as B2P plans for this global scaling strategy, this work that they're doing to visualize it will really support conversations with funders, governments interested in investing in pedestrian infrastructure, allowing the organization to visualize where all of those barriers to access still exist, and ultimately work more effectively with its different government partners and other service providers to address those gaps. And to reiterate, right, in this customer example, Bridges to Prosperity used their data to create routes so they could see how much impact their prospective bridge could have. For your own day-to-day business, the same routing function applies to lots of different applications. Retail site selection, healthcare companies looking at accessibility of facilities, advertising agencies working to place campaign resources around a point of interest, you name it. So if this is something you want to do, this is pretty new functionality within Tableau. So if you're interested in doing this, we definitely want to hear from you. I'd recommend starting by exploring the documentation pages for our isochrones and directions APIs, and then reaching out to us directly to set up some time to talk through what a custom implementation of this could look like with one of our experts. Okay, so to recap, I talked about my favorite Tableau map features, satellite, admin data, and layer toggling. We looked at Atlas for offline maps, at geocoding to enrich your data with that extra lat-long information. And then we also looked at isochrones as this powerful tool for identifying accessible areas, whether you're a real estate company, a bank, or an impactful NGO in rural Rwanda. So if you have not already, please sign up for a Mapbox account and start testing out some of these tools so you can let us know what you think and what else you want to be able to do. We have a bunch of these great examples. What you're looking at here are a couple example Tableau dashboards that you can find at mapbox.com/Tableau. And we'll be sharing more resources in the follow-up email tomorrow, specifically around geocoding and isochrone shortly. So thank you very much.
Great, thanks, Hannah. Okay, let's get to some of your questions. If you have any more questions, just go ahead and submit them now. So Capri wants to know if we provide elevation data.
Do we provide elevation data? Yes, we do. So there are a couple different ways that you can access that elevation data. We have it as like a visual representation in our map styles, and you can also access it through the RGB raster layer. So depending on if you just want to incorporate that as like run a query on it or include it as a visual layer in your map, both of those things are possible. So I would check out the Mapbox documentation and do a search for elevation data.
Great. Glenn was asking, is this in Tableau? And I believe this was when you were showing an example. I think it was in Studio, and you were increasing or decreasing the opacity of something. Was that in Studio?
Yes. Yeah. So I should talk a little bit more about that, actually. So what you get in Tableau are these custom styles that we've worked with the Tableau Maps team to create that are really optimized for data visualization in Tableau. But what you can do is you can use Mapbox Studio to create a custom style, messing around, like turning the different knobs to adjust the opacity, to add new layers, and then you can save that as a custom style and bring that directly into Tableau, using it as the backdrop and default base map for all of your data. And if you're looking for more resources on that, that's a well-documented process that you can find in either the Mapbox documentation or the Tableau documentation.
What are the databases that are compatible with Mapbox?
Interesting. Would need a little bit more information on what exactly you're trying to do. happy to talk more. We have the ability to integrate with all different types of databases and support the upload of data directly to Mapbox or do a client-side data join. So would be curious to understand what you're using and how we can help.
Do we offer anything in regards to a census tract?
Yes, we have census polygons that you can use as part of enterprise boundaries.
So David is Bay Area also,
Mm-hmm.
and he wants to know what data source would you recommend to get the latest fire data to integrate into Tableau?
Ooh, good question. So that data that I was using, I got from someone on the team who's been supporting a couple emergency response groups. I can follow up on that if you want to send us a note, and happy to connect you with a version of that data that you can use.
And in regards to Atlas, is there an additional charge for that?
There is, yeah. So the pricing depends on what the installation really looks like, how many instances you need. So it's very customized, and would be happy to talk through what it looks like for your specific use case. If you want to reach out, we can chat.
Who provides the geocoding engine? Mapbox, Tableau, or third party?
So it is Mapbox. Those requests are going to the Mapbox geocoding API. And then what we're doing is returning the lat long that then you can plot on a map in Tableau. So it's all powered by Mapbox.
Is it possible to get elevation base of lat long, similar to how we get an address?
Doing like a query for the elevation. Yeah, it is not quite in the same way, but as I mentioned before, we have RGB elevation data, which is a raster format of data. You could do like a tile query request to select the elevation for a particular location. Happy to share some more resources on this as well. If you want to reach out, we can set you up with some more information.
Is there a limit for geocoding queries for the free account?
In terms of like a rate limit? Yes, there is. So that's a good question, and something that when I mentioned like we've set up something to do this at scale, there are a couple different options for doing this. So happy to talk more, would want to understand exactly how many requests you're trying to make, and we can go from there.
And is there a cost per query for reverse geocoding?
Yeah, good question. So the way that our pricing works for geocoding is it's all pay as you go, very transparent. If you go to mapbox.com/pricing, you can check that out. And basically, yeah, so head over there and you can see what the pricing looks like, and set yourself up so that you're paying as you go for any requests that you're making. We have a free tier, and then the pricing kicks in from there.
Another elevation question regarding isochrones. Does it include elevation? So, for example, it takes longer to walk up the hill than...
Great question. I'm not sure. It should, but I'm not sure if that's a current feature of it. Would be really interested, would love to hear more about what use case folks are interested in that information to help answer, and definitely know that this is something that the team is thinking about. The directions team is how to inform a more accurate ETA around that. So any customer stories or use cases would be great to support that work.
Can we do any 3D visualization using Mapbox and Tableau?
Interesting. Yeah. So yes. So if you go to the Tableau Mapbox extension, we created this extension that enables you to do 3D, some hex bins, and a couple other different cool features, check that out and let us know if it meets your needs. Specifically, that's around like extruding data. So if you want to make 3D buildings, or if you want to visualize population data in a 3D way, you can do that. If you're interested in like 3D terrain, that is something that the team is currently working on, and I am very excited to see what that will look like in Tableau. Would love to hear how you're thinking about using it, or what use case that would inform for you.
Okay, so Ronan wants to know if there will be a webinar for Mapbox using Power BI. We can definitely get that scheduled for 2020.
Yeah, great.
And Adam wants to know, can administrative boundaries be edited in Studio?
No, but I would be curious to understand what the use is behind that question. So the boundaries themselves, you can't edit the individual nodes of the data. But one thing I should mention is that Mapbox supports a couple different worldviews for different disputed boundaries and territories globally. So if you can find more information about that in our documentation. So you can actually set the worldview that you want to have reflected on the map. Say that you're making a request from India or from China, and you want a different version of global borders to be displayed accordingly. You can set that up and have the map automatically display the version that you're interested in. We're adding some additional worldviews in 2020. So if there's anything in particular that you'd like to see included, we'd love to hear from you on that. And if there's another use case for editing those boundaries, would love to hear about that too.
What about the other Mapbox features like tilting, panning, and zooming? Are those available in Tableau?
Not currently, but
if we didn't get to your question, there are lots of questions.
Awesome.
We'll follow up with you offline. So let's see, our last question. What types of open source tools other than your geocodes? Nicer code. What types of open source tools other than your geocode?
I don't know if I understand that one. Maybe we can follow up offline. Yeah. Cool.
So let's see. We have lots of data with street addresses, zip codes, and that model where sometimes one or the other is missing. Is there a way that Mapbox could help us automate the completion of the missing data?
Wait, can you say it one more time?
So there's lots of addresses where we have either zip codes or lat longs, but not the full data. Can Mapbox augment that? What's missing?
Yes, we could definitely talk about how to set up a script that would search for those empty fields and then automatically make the request to fetch the lat long for those different missing pieces and update the spreadsheet of data to make sure it's complete. It might require a couple other tools in addition to Mapbox, but the primary thing would be making the request to the geocoding API, and that's definitely something we can help with. / would be happy to talk about what a fully baked solution architecture would look like on that front.
Okay, great. Yeah. So we do have a lot of questions left.
So many good questions.
We will follow up with you offline. You will get an email around the same time with the link to the recording along with additional resources that Hannah mentioned.
Awesome.
Thanks, Hannah.
Yeah, thanks so much, everyone.